Hi students, welcome back. In this video, we are going to discuss about sampling distribution of F statistic and how to summarize the ANOVA table whatever we have calculated. In the previous video, we have stated the null and alternative hypothesis, and based on that we have computed a test statistic. So basically in any testing of hypothesis procedure, the test statistic must follow a sampling distribution, for example T, F and chi-square. In the same way, the sampling distribution of F ratio is a F distribution. So from this distribution, we get to know what is the critical value for F for a particular degrees of freedom, for treatment degrees of freedom k minus 1 and the error degrees of freedom n minus k. So this particular critical value we will obtain from the F table. So this is the figure for the distribution of F distribution. So it is a positively skewed distribution, and you have a line called 2.23. So this is given for an example. So that particular line which is cutting at 2.23 is nothing but your F critical value for any hypothesized degrees of freedom. So this is how the F table will look like. So we will see what is the numerator degrees of freedom. So just recall what is the numerator in our F test. So in F test, the numerator is between sum of squares. So for between sum of squares, we have 1 degrees of freedom. So that you should see in the column, and then in the denominator we have the degrees of freedom for error, that you should see in the rows. For example, if you have the numerator degrees of freedom as 4 and the denominator degrees of freedom is 10, so whichever is the intersecting point, that is 3.48, must be our F critical value which is coming from the F table. So using this value only, we are going to decide our hypothesis to be rejected or accepted. So before moving into the decision rule, we should summarize whatever we have computed so far in a table, what is called ANOVA table. People call it as a summary table. So here we have various components. So the first component is the source of variation. So where exactly the variation is coming from the treatment, within and total, and we have a sum of squares for treatment, sum of squares for within, that is error, and total sum of squares, and what is the degrees of freedom related to treatment, related to error and the total degrees of freedom. And then we have mean sum of squares which is computed from dividing sum of squares for treatment divided by the corresponding degrees of freedom k minus 1. Again the mean sum of square for error can be computed by dividing within sum of squares by the corresponding degrees of freedom. And then we will move to find out the F ratio, which we divide SB square by SW square, that is mean sum of square for treatment divided by mean sum of squares for error. Now we move to write our conclusion. So in addition to the ANOVA table, so this ANOVA table is only the byproduct of the output which is produced by the statistical packages. Whenever you are reporting the conclusion, you need not to write the table for writing the conclusion. Instead of that, you can report the important values, such as you can report F statistic, critical value, p value, degrees of freedom for treatment and degrees of freedom for error and total degrees of freedom, etc. So how you conclude? So you have to conclude like, since the observed F statistic value is greater than F critical value, reject H naught at alpha level of significance and conclude that there is no difference between the mean of K population. So the phrase there is no difference between the means of K population is coming from our alternative hypothesis, since we have rejected our null hypothesis H naught. Suppose if we are not rejecting our null hypothesis, we have to state we do not reject H naught and we conclude that there is no difference between the means of K population. Now we move to write the conclusion. So previously we have summarized the ANOVA table, so which is the byproduct of output of the results coming from a statistical package. So, you no need to write the table as such in your conclusion. Instead of that, you can report the F statistic, critical value or p value, degrees of freedom for treatment and degrees of freedom for error. Suppose if your observed F statistic value is greater than F critical value, then you reject H naught at alpha level of significance and conclude that there is a difference between the means of K populations. Otherwise, you do not reject H naught and you conclude that there is no difference between the means of K populations. In this video, we have discussed how to find the distribution of the test statistic, that is the F test, and then we have understood how to find critical value from the F table based on the t test and the test statistical value and the critical value. We have made a statistical decision. Overall, in this lesson, we have discussed how to describe the data, how to validate the assumptions of the data, setting up of level of significance, and then stating the null and alternative hypothesis, computing the test statistic, finding out the sampling distribution of F statistic, and obtaining the critical value from the F table, and based on the test statistic and the critical value, how to make statistical decision, and then how to write conclusion and report the results. We will meet in the next video. Thank you.